Hello students, so today we will continue with chapter 1 physical world. First I will teach you fundamental nature of forces. We have studied about forces in previous classes, that force is that thing which pushes the body or we pull the body, or to be more scientific, we have told that force is that which changes the motion of the body. If the body is stationary, the body may move. If the body is moving, its direction may change or its velocity may change. Initially, Aristotle had told that force is required for moving a body, but afterwards Newton explained that the body that we see gets stopped or its motion changes because there is frictional force on the body. If friction is absent, the body will continue to move in a straight line unless some force is applied. So this is force we have studied. Now various type of forces we are encountering in our daily life. For example, buoyancy force. If you put any body in the water, the weight force acts downward and the upward thrust, which is called buoyancy, acts upwards. If we take a spring, extend it, the force will act to bring it back to its normal position. If we suspend a load in some rope, the rope comes under tension. Even in gases, there are forces called van der Waals forces, which are keeping the molecules at a small distance from one another. Now all these forces, we will try to bring them into minimum number of forces. As I had explained to you last time, that one thrust of physics is unification. Means you don't have variety, you mix few concepts, few laws which would be applicable in a wide variety of cases. From this point of view, as on today, we have got four types of forces. Two comes under macro, M-A-C-R-O, macro forces, and two comes under micro, M-I-C-R-O, micro bodies. Okay. Now, let us first understand macro forces. There are two forces. One is gravitational force, other is electromagnetic force. Let us try to understand its properties. You know, gravitational force is the attractive force between any two bodies kept some distance apart. But we don't see the movement of the bodies due to this, because the bodies are quite light. But Earth pulls the body down. We see that everything falls on the Earth because the mass of the Earth is quite large. We will be learning in the chapter of gravitation that this force of attraction in two bodies is equal to G multiplied by M1 M2 upon R square. So R is the distance of the two bodies having masses M1 and M2. So this is, we say that this force obeys inverse squared law because the distance square is coming in the denominator. Now let us try to learn its properties. This is long range force. What do we mean by long range? Long range means the bodies can have a very large distance from the Earth, or between the two bodies the distance can be very large. Now if the distance is large, the force will reduce, but there will be some attractive force. Then we say it is a central force. What do we mean by central? Central means that in case we have two bodies, okay, so in case we have two bodies, these are the two bodies, and these are the centers of them. This is the center of this body, this is the center of this body. The attractive force is along the line joining the centers. So we say this is a central force. Then we say this is a conservative force. It's very important for you to understand the meaning of conservative force. Conservative force means that in case I move a body from point 1, this is the point 1, I am moving body from point 1 to point 2. I am moving in a straight line joining 1 and 2, or I can move it in a curvilinear as shown in the figure, or I am moving it in this manner. In whatever path I follow, the work done in moving the body from 1 to 2 would remain same. So once it remains same, we say it is a conservative force, because from 1 to 2, if the work done is W1, then from 2 to 1, whatever path I take, the work would be now minus W1. So total would be 0. So this also we say if a force is conservative, then in case a body is moved from that point to another point and brought back to the same initial point, then the work done is 0. Is it okay? And other property of this is that this does not require a medium between them. Between 1 and 2, we can have vacuum, we can have any material, even then that force will act. So this was about gravitational force, about which you were somewhat familiar. Now we go to another type of force called electromagnetic force. Now as the word electro means electric, magnetic means magnets, from magnet. You know that if we take two charged bodies, like you have studied in your 9th standard, I can have a glass rod, charged glass rod, I can have a charged ebonite rod. So if I take two charged bodies, both are having same type of charge, then they are called like charges, then the bodies repel. And in case I take two bodies having unlike charges, they will attract. Now this force is also given by, in a similar manner like this, instead of G, constant is 1 upon 4 pi epsilon naught, and instead of M1, M2 it is Q1, Q2, and R square remains the same. So this electrical force also, this is called electrostatic force. Force between two charges which are stationary is called electrostatic force. So electrostatic force is also having inverse square law. Now M1, M2, it will become Q1, Q2. So both the charges are of same type, then product would be positive. And in case they are of opposite sign, then the answer would be negative. Therefore, electrostatic force can be attractive, can be repulsive. If it is attractive, the answer is negative. Is it alright? Now, in a similar manner, instead of charges Q1 and Q2, I can have magnetic poles. And the magnetic poles also do not two types, north and south. So two magnets or magnetic substances repel one another or attract one another in the same manner. So all these forces are long range forces. Distance increases, force will decrease, but there will be some force. And okay, now the major difference between gravitational and electromagnetic force is in the order of magnitude of these forces. Electromagnetic force is 10 raised to 36 times stronger than gravitational force. So electromagnetic force is 10 raised to 36 times stronger than the gravitational force. You may not, it becomes a bit unbelievable. I will give you an example that will give you, clarify this point. When I write with a marker on a board, then marker is liquid, board is solid. The liquid does not flow down to the ground. If you take water and write on the board, water droplets will fall on the ground along the board. But the marker ink does not drop, it remains stuck to the board. Why? Because of electric force. The net charge of the ink and the charge on the board attract one another, and so therefore the liquid does not drop. So this example will explain to now to see. So means my electrostatic force is more stronger than gravitational force, therefore ink is not dropping down. Ink is getting held up by the attractive force of the board particles. Is it alright? As such, this electric and magnetic effects, they are inseparable. Why? I will give you that when electric charges flow or when electric charges move, you can say, they produce a magnetic field around it. So moving electric charges produces magnetic field, and force acts on the moving charges in magnetic field. So what we say, if electric charges means electric field is changing, it produces a magnetic field. And also when magnetic field changes, a force acts on the electric charge. Therefore these two things are combined together, so it is called electromagnetic force in general. So this is called electromagnetic force. As I told you, it is also long range force, central force, conservative force. Only its magnitude is much more than gravitational force. Now this electromagnetic force is dominating at very small distances, which is say atomic or molecular scales. Means atomic is 10 raised to minus 15, nucleus is 10 raised to minus 15, atomic is 1 angstrom. So at these distances, small distances, electromagnetic force is dominating, and as this is much stronger than gravitational force, so gravitational force normally we neglect when this force comes into picture. Like electrons are being attracted by the protons in the nucleus and they are rotating, that's why in the various orbits which we will be studying in physics as well as chemistry, it decides the orbital radius. So that is electromagnetic force. Then in chemical reactions, what happens? A plus B forms C and D. You might have written various equations in your 10th standard. There is rearrangement of molecules, some rearrangement of atoms. Some atom from A will go to B and some atom of B will go to A. So they rearrange and form different products. So here also electromagnetic force plays a major part. Therefore chemical reactions, kinetics depends upon the electromagnetic force. So it depends upon the properties of the substances. Similarly, all properties, mechanical, thermal, depends upon the electromagnetic force that is dominating on the atomic molecular side. Molecule means it is having various atoms. Now, how are the atoms to be located at what distances? So that is also decided by the electromagnetic force between atoms. Now you see these microscopic forces which I was mentioning, tension, spring constant, friction, they are also due to electromagnetic force. If we think, what is tension? Tension means you can consider a spring. So if I elongate the spring, then the atoms, neighboring atoms attract one another and they want to come back to its original state. So what is the force of attraction for the atoms to move? So that is electromagnetic force. So all these forces, tension, friction, spring constant, they are governed by electromagnetic forces. But in terrestrial, like means in macro, MACRO, between two bodies, between Earth and satellite, Earth and Moon, if all those here, gravitational force dominates, because the distance is so large that electromagnetic force is almost nil. So only gravitational force will dominate and it will take place. Other thing, that gravitational force is between neutral, bodies are neutral. Moon and Earth, they are neutral bodies. So there is only gravitational force. Electromagnetic force can't act only when the two atoms come very near to one another and the atom is having some net charge, then only our electrons of the atom get attracted by the nucleus of the neighboring atom of Earth. So there is electrostatic force come into picture. So for terrestrial phenomena, when the distances are large, bodies are neutral, only gravitational force will dominate. Is it all right? So that was about micro forces. Now we'll go to micro bodies. Bodies very small size, of the order of 10 raised to minus 10 to 10 raised to minus 15 meter. Now here, as I told you, there are two types of forces. One is called strong nuclear force, other is called weak nuclear force. It's very easy to understand strong nuclear force. You know, in nucleus, which is of very small size, 10 raised to minus 15 meter, there are various protons in it. So these protons are like charges, so they should repel one another and come out. But no, they don't come out. They are remaining in a very small space. So the repulsive force between protons is overcome by the nuclear force, which we are calling strong nuclear force. So there is a strong nuclear force between proton and proton, proton and neutron, neutron on neutron, or between any two nuclides irrespective of their charge. So irrespective of the charge, there is a nuclear force which is binding or keeping together all nucleons in a small space called nucleus. So that is why protons are not getting repelled, because this strong nuclear force is 100 to 1000 times stronger than electromagnetic force. So this force is so large that electromagnetic force becomes very weak and it plays no part. But this force is also short range force. It acts only over the size of 10 raised to minus 15 meter size of the nucleus, and in case I decrease the distance to less than 0.5 into 10 raised to minus 15 meter, then it becomes repulsive, so that it will come back to its original size. And if we increase the distance, then the force decreases. Therefore, there is no force between nucleons and electrons, because electrons are at a much larger distance than 10 raised to minus 15 meter. So there is no nuclear force between any nucleon and electron. Okay? Then we'll go to other force called weak nuclear force. As the name suggests, this is weak nuclear force. So means its strength is quite small. But it is, though we say it is small, but it is 10 raised to 25 times more than gravitational force. It is small as compared to strong nuclear force or electromagnetic force. Now, where this force comes? This, whenever we have studied in the 10th standard in the chapter of radioactivity, that sometimes there is a beta emission. Radioactive materials emit beta particles. Beta particles are nothing but electrons. So, there are no electrons in the nucleus. Then how electrons are emitted? Because neutron gets converted into proton and electron, as shown in this equation. You see this equation. See this equation. Neutron is getting see this equation. Read this equation. Neutron is getting converted to proton plus electron and one another particle that is called anti-neutrino. Initially this was not known. We were telling neutron is getting converted to proton plus electron, but studies and experiments conducted show that anti-neutrino is also emitted, comes out along with beta particle. Whenever beta particle will come, anti-neutron will be emitted, will also come out. Therefore, we are finding that the energy of beta particle, when this electron, is varying, is not constant, because there is some weak force between electron and anti-neutrino, so that changes the energy between the two. And positive electron, which is called positron, is emitted when proton gets converted to neutron and positron. And then at that time we say neutrino is emitted. Is it all right? So weak nuclear force is in any nuclear process connected with light subparticles like electron or positron. So whenever such particles are emitted, then weak nuclear force come into picture between the electron and anti-neutrino or neutrino, or electron and some neutron and proton also. So we say elementary particles. So weak nuclear force are forces which causes light elementary particles to interact with one another and with heavier particles. Is it all right? So this completes the topic of forces. Next time I will explain you last topic of this chapter, namely nature of physical laws. Okay, thank you very much.